Hey everyone, this is Andrew Kroll, and this is part 3 of how to make a really crappy NES ROM. Last time, in part 2, we managed to embed a tileset asset into our ROM, and we loaded a basic grayscale palette into the background palette section of the ROM. Now, we did this, and the result is this ROM right here, where we have this black screen. And if we look in the PPU viewer, we actually see the tileset art that we embedded into the ROM. Now, the thing is, we're not actually drawing anything to the screen right now, and we'd like to change that. I'm going to see if I can just like whip through this really fast. So, I don't know, for starters, I think I'll just explain a few things. So this screen here that you're seeing in the emulator window is scaled up a little bit, but the NES native resolution is 240, oh wait, I might have actually clipped a bit of this, so this isn't very good. I'm going to show you a screenshot actually. So here's a screenshot of Final Fantasy, the original for the NES. And if you see, you got like a little overworld map here. This screenshot is 256 by 240 pixels. I've zoomed in quite a bit. And yeah, so here, this is the full size of an NES screen. And normally you don't actually see this full screen because emulators and televisions both like to cut off quite a bit of the outer margin, so you might only see like from here or something like that instead of the entire screen. So any details that are near the top like the outer edges of the screen are not very safe for display. So yeah, a lot of that shit will get cut out. So if you had HUD on the screen, yeah, anything outside would basically not be visible. Or it really depends on your monitor. But yeah, there you go. And the other thing is, yeah, so what you'll notice is this is like a tile map. There are a couple sprites, so like these the airships, the airship, the dude, and the boat. They're all sprites. Then everything else here is just basic tile art. So yeah, the way that this actually is structured, so the screen is 256 by 240, and it's subdivided into little 8 by 8 chunks. So 8 by 8 being like about that size or so, and basically just think of this as a giant grid. So now that you know that, you should know that. Yeah, so dividing the screen into 8 by 8 chunks makes this entire grid that you can form from 8 by 8 pieces, it'll be a 32 by 30 grid. So 32 little tiles going along, and then 30 going down. And yeah, so that's what they use to basically structure the map. And the other thing you'll have to know is that on top of that, they have attribute regions, and the way they do this is they divide the screen into 8 equal chunks, or roughly equal. They have to like kind of make exceptions for the bottom row of the screen. But anyway, so there are 8 chunks to this map, or 8 by 8 is what I mean. So there's 8 across and 8 down, and inside of those 8 by 8 regions, they have, so the region is about this big. Inside of these regions, they have 16 by 16 subregions, which are like this, and those subregions define the palette for each area of the screen. So you have your 32 by 30 pattern. So all these little like values that you see here, like this pattern here, the texture that you see without any palette applied is what's selected by the 32 by 30 grid, and then over top of that you have a palette grid, which basically or attribute table as they call it, that they basically just use to define what colors to display, or how to actually draw the patterns on the screen using the NES palette. So yeah, we have like this blue ocean here with green grass, and then there's another palette over here with a green highlight and green grass, and this black I believe is the background color that's common to all the palettes. Yeah, and then they have another palette here that's like gray scale and green, and yeah, or maybe green is the common color actually, I'm not sure, it's hard to say, but it doesn't really matter. You seem to use green and black in both of them, so anyway, so there you go, there's a breakdown of one little screenshot. So yeah, let's make a shitty tile map appear on screen. So if we go back to this Explorer window here, if we open up molasses.chr, we see this tile set here. Contains a bunch of tiles, and what we want to do is actually take these values here. So they go from 0, 0 to FF. This is 255 tiles. Now we want to actually draw some of these. So let's say we want this heart pattern. So we notice in this area of the status area here that I'm mousing over right now, if you will watch it while I move my mouse back up, you'll notice it says bank 60 and bank 61, bank 70, bank 71. Those numbers are, oh, and I shouldn't say 61, it's 6061717071. Yeah, these are hex values, and they basically define the area. Yeah, they define, yeah, the hex value is basically the number to look up that tile in the tile set. So if we actually hardcode a map with those hex values, we'll get a nice little tile map out of this. So let's just go ahead and do that then. If we go back to our code here, we can actually create something really quick. Let's just create a new label called map. Now we're going to embed a bunch of bytes. So keep in mind there are 32 tiles. So we want 0x60, then we want 0x61, and if we want that, so that's our top row of tiles. Then our next row we actually want 70 and 71 a bunch of times. Now we want to repeat this pattern a bunch so we can fill the entire map. So there's 8, so 8, 16, 32. Just to make sure, let's double check that. Okay, so that's 8, so that's 16, and that's 32. Okay, and now we need to do this again for the next row. So 4, 8, 16, 32. Alright, now we just need to duplicate these rows a bunch of times. So there's 4, 8, 16, and just to make sure, that's 32 lines, but the grid is actually 32 by 30, so there's a 32 by 30 map. Now next we need the attribute table, which is 8 by 8, so if we just fudge in a bunch of attributes here, 1, 2, 3, 4, there's 8. Now we just paste this 8 times. There we go. So this part here is attribute table tile table, and Yeah, so there we go. That's our little grid there. Now, if we actually take these values and we want to draw them to the screen, so this is our 32 by 30 grid. This is our 8 by 8 grid of attributes. Combined, they actually define what the screen will show on the NES. And you can muck around with the palettes and stuff to see different effects. And yeah, just, I don't know, dig around. There's also documentation on NESDev Wiki and a few other places that you can actually look at. So now, to do the setup for this, we need to basically make a quick loop. I'm going to copy and paste some code that I already wrote here, where I just set the address to palette base. Now there's another address area called the name table base area, and if we write to that, or we tell the PPU address to be that, and then write a bunch of data, then we'll be writing to the basically what gets shown on the screen. Name tables are just grids of tiles and attributes which make up the screen that you show. So yeah, if we want to actually draw things to the screen, we need to make a loop, and the easiest way to do this, we copy and paste some more. So we have this loop that starts at 0, and we're going to copy map at x into the PPU data register, and next we need to increment x, and because we're copying a bunch of crap and it's going to be more than 256 bytes, we actually need to wrap around and just keep going until we hit 0. Now, something convenient is that when you add up 32 times 30 and 8 by 8, you get exactly 1024, which is 1 kilobyte. And basically that means if we do this loop that I'm doing right here, we do this 4 separate times, that's 256 bytes, another 256 bytes, another 256, another 256. You add those together, you get 1024, which is how many bytes this entire table takes to draw a map. Now that is a lot of memory, and you can, if you know that tiny screen that you saw, like that little FF screenshot you see here, you realize that takes up a kilobyte of memory if you were to store that uncompressed without any special data storage or anything. You realize that that's really inefficient, really fast if you have a big game. But for now, since we're only doing a demo, this is the easiest way to just draw shit to the screen, so we're just going to do this. So yeah, we have 4 loops. Now the thing is, we need to change these subtly. Well, we don't have to for the pattern that I did, but if you wanted to actually use all the data in this ROM here, we actually need to number these from different rows. So the first loop, we're copying 256 bytes, we wrap around, and then we exit loop. Now the next loop needs to start 256 bytes after that, and then the next one needs to start another 256 bytes after that, and the last one is another 256 from that. And now that we've got that, we've basically set up our little grid. So if we go back over to build, we should get a nice little blank screen, but if we look at the name table viewer, we see a bunch of hearts. Now that's cool. Now why didn't it show up in the actual, why didn't the screen actually display anything? Well, the answer is simple, and if we look at our main, we'll notice that we turn off the rendering earlier on. Now we don't need to do that after we're done, or sorry, we need to do that while we're setting up different video memory, but after we're done doing all of this shit, we want to turn the screen back on. So basically, we want to write something to the PPU control register. We just want to say in the NES PPU control register, write NES PPU control NMI. This will allow us in a later video to actually be able to use this draw task here to actually update the screen on the fly a little bit at a time. Because yeah, some drawing you don't want to do with the screen off. You actually want to do it on the fly and do little tile animations and sprites and stuff. So this is how you do that. Next up, we have PPU mask, which we also need to set, and the mask defines what actually, like, it defines things that actually get rendered on screen. So we want to set up the NES PPU mask render BG. And we want to OR that, this little pipe means OR, we're going to OR that with sprite rendering, and on top of that we probably want the leftmost sprite and leftmost background to be rendered. And technically we don't need sprites yet, but we will later, so this is kind of getting us ready. Oh yeah, and both of these need a via A at the very end of that, so we can avoid having to write two lines where we first assign A to this value and then set the value to A. This is just a way to get around that. Yeah, so you put the via A at the end, and then it'll just assign this value into the A register, and then it'll assign that thing into A, or whatever. There you go. So now that we've done that, if we hit build, we'll look here, and voila, we have a screen full of hearts. So that's our little demo for now, and since I have to catch a train in like 15 minutes or so, I'm gonna call this video quits and catch you later. Okay, bye.